All right, welcome to lecture number 6. We're working on section 2.5. So we're looking at solving equations, but real quick, what is the difference between an equation and an expression? Well, an equation has an equal sign. Think of the word equa. So for example, x plus 3 equals 5. That is an equation because there's a equal sign. An expression, on the other hand, would be something just like x plus 3. There's no equal sign. Okay, so now we're focusing on equations. So it's a different land and there are different rules in this so-called land. Okay, so if you see an equation with an equal sign, these are things we can do with them. So the first thing we can do with equations is called the additive property of equality, shorthand APE. In an equation, the additive property of equality states that if we add or subtract the same number, that's a key, to both sides of an equation, the sides remain equal. Symbolically, we see this. If you have A equals B, then you can add C to both sides. Or if you see an equation A equals B, then you could just subtract C from both sides. So for example 1, x plus 47 equals 26. So if I wanted to solve for x, I want to get x by itself. And the question is, what is keeping x from being by itself? Well, that plus 7 is keeping x from being by itself. So I want to get rid of it. So to get rid of a positive 47, we're going to subtract 47 from both sides. And some students like to draw a line down the middle. I'll accept that in my class. Other professors might not accept that, but it's up to your professor as you go through math classes. So we keep that equal sign on both sides. So x equals, let me write that in black, sorry. So 26 minus 47. What is 26 minus 47? That's negative 21. So my answer is negative 21. All right, the next one. Well, we're trying to get y by itself. So I want to get rid of this negative 1/4. Well, how do you get rid of a negative 1/4? You're going to add a 1/4 to both sides. So y equals negative 1/3 plus 1/4. So we can create common denominators there to add or subtract the fractions. So negative 4 plus 3 over 12 is going to be y equals negative 12. And that is my solution for C. Oh, interesting. So I want to solve for n, but n appears on two different sides. I have n here and n here. Well, I want to get n by itself on one side, so what I'm going to do is I'm going to get the n's to one side and the numbers to the other. So I will subtract the 8n from both sides. Which means I'm left with the 5 on this side, equals to 7n minus 8n's. Well, we have 7 minus 8. So what is 7 minus 8? Negative 1. So we have negative 1n. But I don't want to solve for negative n. I want to solve for n. Oh, real quick, pause. Notice I didn't write negative 1n. I wrote negative n. They're the exact same thing. You can write this option, but most of the time mathematicians will choose to just write the negative n. Okay, so back what I was saying. We have 5 equals negative n. Well, I don't want to solve for negative n. I want positive n. So I'm going to go ahead and divide both sides by negative 1. And when I do that, the negative times the negative cancels out. 5 divided by negative 1 is going to be negative 5 equals n. So next one, multiplicative property of equality. Very similar to the additive and subtracting property, but this time we're working with multiplication and division. So in an equation, the multiplicative property of equality states that if we multiply or divide the same number, remember we're working with the same number here, to both sides of an equation, the sides remain equal. Symbolically, it is shown as if you have an equation, you can multiply both sides by x, or if you have division, you could divide both sides by z, the same number. So you can multiply both sides by the same number, or you can divide both sides by the same number. And remember, the key thing here is you're looking at each side of the equation. And what is a side? Well, the side is what is split up by the equal sign. So that's one side, and that's the other side. Okay, let's use this property. Well, I can go ahead and draw that line. If you feel it's helpful, you can use that line. So I want to solve for m, and at the moment m is being multiplied by -4. How do we undo multiplication? Well, we undo it by division. So we're going to go ahead and divide both sides by -4. So now m is by itself. Awesome. Well, what is 16 divided by -4? You could check that on your calculator. It's -4. Or if you already had that in your head, awesome, -4. Next one. You might be tempted to say we're done and our answer is right there, but remember, we're not solving for -x, we're solving for x. So we're going to multiply both sides by -1. So x equals -15.3. And the next one, -2/3n equals 10. So our problem, our variable here is being multiplied by a -2/3. So here's a little trick. What we're going to do is you're going to multiply both sides by the reciprocal of your fraction. Reciprocal means the flip. So notice it used to be 2/3, and now we're multiplying it by 3/2. So we'll multiply that to the other side as well. Okay, remember multiplication property. Multiply both sides by 2/3. Sorry, 3/2. So once we've done that, these values will cancel, and we're just left with n on this side. Awesome. So now we have 10/1 times -3/2. Divide both sides. We can simplify with the 2. And we're left with n equals 5 times -3. I'll rewrite this. So that answer is going to be n equals -15. All right, so that's a good trick to know. If you ever see that fraction, you just multiply by the reciprocal. So now we're going to look at problems that involve both the addition property and the multiplication property. All right, so most of the time when you're doing this, first you're going to look to see if you can use the addition property. That's going to be first. After that, look for ways of using the multiplication property. So for this first problem, let's do this together. Here's my equal sign. I want to solve for m. So m is right here. What is keeping m from being by itself? That 2 and that -4. So to get rid of that +2, we're going to subtract 2 from both sides. And we're left with -4m equals, well, -14 minus 2, that's going to be -16. Now, m is still not quite by itself yet. We need to divide by that -4. Then m is going to equal negative divided by negative is positive. 16 divided by 4 is 4. And b. Go ahead and try to see if you know what we should do first. Okay, so the first thing I would do is get rid of that 15 there, because we have that 15 being added and that 2 being multiplied. So that's -15 from both sides. Okay, and now my y is being multiplied by -2. So let's divide by -2 from both sides. Then y equals 9. -18 divided by -2 is 9. And the last one, ooh, that one looks kind of interesting. Where is q? Oh gosh, q shows up on 2 different sides, which means I need to get the q's together. So I will go ahead and choose to move the q's to the other side. So I'm going to subtract 4/3q. from both sides. Which means I'm left with negative 1 equals 1 over 3q minus 4 over 3q's. So 1 over 3 minus 4 over 3q's. That's going to be negative 3 over 3q's. Well, what's negative 3 over 3? 3 over 3 is just going to be 1. So that's going to be negative 1. So negative 1 equals negative q. Okay, notice my equal signs are all lining up as I'm working. Well, I don't want to solve for negative q. Remember, I want to solve for positive q. So we're going to divide both sides by negative 1. And I'm left with q equals 1 divided by 1 is 1. Negative divided by negative is positive. 1 equals q. That's the exact same thing as q equals 1. Either answer would work. All right, so the last thing we're going to do is figure out how to check our answers after we've solved. So for A, I'm trying to solve for m. So to get m together by itself on one side, we're actually going to add these together. So negative 3 plus 2 is going to be negative m equals negative 10. Well, I want that m by itself, so I'll divide by negative 1. And I get m equals 10. Okay, so to check my answer, we're going to compare both sides of our equation. I want to see, if I plug 10 where m is, do I get negative 10? So let's see, we have negative 3 times our answer we said was 10, plus 2 times I said was 10. And I want to see if that gives me 10. Well, negative 3 times 10 is going to be negative 30, plus 2 times 10 is 20. That's going to equal negative 30 plus 20 is negative 10. Aha, they're the same. My answer is correct. So remember, when you check, you're just going to focus on one side and see if it ends up equaling the other side. Okay, there's no moving things around when you're checking. Let's go ahead and solve this one and get back to me. All right, m is on two different sides, so I'm going to move the 1/3 m to the other side. So that's going to be 2/3 minus 1/3 is going to be 1/3 m equals 5. Well, we have that fraction going on, so I'm going to use that reciprocal method. So m is going to equal 15. So to check my answer, I'm just going to compare these two sides and see if they get the same answer. So 2 over 3 times m, which I said was 15. So 2 over 3 times m. And then I want to see if that equals this side, which is 5 plus 1/3 times 15. So we're going to work on each side separately and see if they end up equaling each other. So let's see. We can simplify this. That's going to be 1 and 5. So 2 times 5 is going to be 10. All right, so we know this side simplified to 10. The question is, what will this side simplify to? Well, I can go ahead and still do some canceling here. So 3 and 15 cancel. And then I have 5 plus 5, which is going to equal 10. So both sides are 10, which is correct. So I know I have this right solution. Okay, so I checked, everything checked out. That was my solution.